official time. Okay, so you are in the right spot if you want to be attending the EMO working group, EAP method updates. Hopefully by now you've all seen the note well. I'll leave it up here for just a couple seconds, but we'll now move on to the request. So again, we have minute takers. Jabber window is, or Jabber's open, and people can talk in it or type in it, and we will try to relay those messages. There are no more glue sheets, it's automatic. So when you're speaking, please state your name and always remember to try to keep things professional. For the agenda, we have just to go over this administrivia, and then we'll start in with TLS-based EAP methods. Alan will give a presentation on that, and then on EAP usability, and we'll have a brief presentation on EAP DPP, and then EAP TLS IBS as well. Does anybody have any additions to this agenda or modifications that they want to make? Excellent, then let's get started. Alan, do you want me to run the slides or do you want to run slides? It doesn't cost you much for me to run the slides, but Alan, are you there?
I'm here. Can you get me?
I can hear you.
Okay. Yep, you can run the slides. So if we go ahead, not a lot. Aligned it with the TLS 1.3 draft based on, we'll go to the next slide, based on John's comments. Use type consistently instead of random variations thereof. Some notes on session tickets, that they must not be valid until after the inner tunnel auth is done. There have been issues with EAP previously where if you don't mangle the TLS layer appropriately, you can connect, not authenticate with stuff like TTLS, and then immediately resume. And so you have to work around that. This is not even TLS 1.3. It's just a note that this was not covered in the previous specs. Updated section 5.1 with notes on protected success and failure indicators. The issue there is TTLS, when you have PAP or CHAP inside, there's no protected success or failure indicators. So the suggestion is you might want to use EAP inside of TTLS to get those. And I think that's actually pretty much it for the slides. The only other comment I would have on this draft is some text I posted to the list the other day based on random unnamed vendors who decided that we should use anonymous identifiers inside of the TLS tunnel. And perhaps there should be text in the document suggesting that's a bad idea. And so that was posted to the list a few days ago, and I haven't seen any comments or updates to that.
What specifically is bad about the anonymous identifiers?
Well, the point is usually you have an anonymous identifier in the outer layer, you know, at example.com, and then when you go inside of that, you have TTLS or PEEP, with your real username, joe@example.com. And some vendors decided just to use the anonymous identifier in both places. So your inner identity that you send along with your password is @example.com, meaning you cannot meaningfully authenticate anyone. So yeah, it's one of these rather surprising things that it got past the most basic QA. So there's about 4 or 5 paragraphs of text in the list, which I'm suggesting we add to the document before the next rev, explaining we should have an anonymous outer identifier so it's routed properly. The inner identifier must not be anonymous, otherwise you don't know who to authenticate. And the inner identifier probably should not have a realm, because you already have one, the outer identifier, and there's no point in having it in both places.
Okay, Sean?
So this is Sean. I was going to ask if you did that, and you answered my question, so I'll get out of the queue. Thanks.
Mohit, did you have anything? Or I guess you're out of the queue.
Just the same question, I guess. I don't know if we know which vendor is doing this, because how it's like if you don't have a username, how do you look up the database to actually do the
Well, exactly. This is, I mean, if you go look, you can find it. It was certain builds of Android. And there were lots of people that I ran into complaining and going, oh God, this is a horrible, horrible issue. And the solution for their customers was to use the full name, including username and realm, as the anonymous outer identity, because that's the only thing you could configure, which would then be copied to the inner identity. And so it works for, various versions of works that people can get online, but now you don't have an anonymous outer identity, which is arguably wrong.
Okay, Jan?
Yeah, you mentioned to strip the inner username. Sorry, this is Jan-Fred speaking. To strip the inner username of the realm, but I can actually think of some rare cases where the routing may have a different realm than the inner username. For example, if different user bases are configured in one server. And also I have encountered some operating systems, Windows especially, which actually uses the realm of the inner username to determine the outer username if an anonymous identity is used.
Yeah, I mean, we can take this to the list for the technical discussions. For me, I have a hard time seeing where those should be different. I mean, if we're going to call the outer identity the routing one, then yes, routing should be independent from your actual identity. I'd want to know exactly what the use cases for that would be, and probably put something in the document saying, hey, this is why you do it. But in general, from my experience, most of the time, those two realms should be identical if you put one in the inner identity, or else the inner identity should not have a realm. And stuff like Windows arguably should configure outer and inner identities as separate items, because they really are.
Okay. So it sounds like this is a discussion we should take on the list. There's a couple, I think, few little things to resolve here. How many folks on the call have read some recent version of this draft? If you could plus one in the chat, that would be good. We have 1, 2. Okay, we need a couple more folks to review this draft so that we can get it to a place and then we can last call it. So I think certainly have the discussion that we need to have. I think it's getting reasonably close, but I'd feel a lot better if we had more folks on the call who have read it. Is there anybody who would want to commit to reading this and reviewing this draft in the next month or two? Silence. Okay. Oh, thanks, Bernard. All right. I'll try to track down a couple more folks to give it some reviews. Anything else you want to talk about on this subject, Alan?
No, I think that's it.
Okay, then we'll move to the next presentation. Sorry, it'll just take me a second to do this. There's probably an easier way.
So yes, this is a bit of a monster draft. It's just under 60 pages and may get bigger. So we go to the next slide. The problem here, the draft goes into this in great detail. EAP is horrible. And I don't just mean the protocols and the implementation, speaking as an implementer. It's hard to use. And there's all kinds of text in the document, politely and anonymously gotten from a number of people about what people do with their UIs, APIs, workflows. And the answer, as we've seen with this anonymous identifier, is people make random changes to everything. This is an indication that nobody knows what's going on. Nobody knows what should be happening. And there's a pain point which needs to be addressed. It's all kinds of MDM vendors selling expensive products for simplification, ease of use. These have their own issues. And as the APIs are changing and breaking, these MDM products becoming less useful. Next slide. So the requirements: device has a network connection, untrusted is fine, slow is fine, root CAs for web PKI, a username and a password, and per Dan's comments on the list, that's a good point. It doesn't actually require the username and password. All it really needs is the realm. But the initial purpose of this draft is end user devices. So we'll just call it a username and password. So if we go to the next slide, what the device does is it gets the NAI from the username, looks up a cert, resource record, gets a URI, which is HTTPS. So you don't need DNSSEC. It doesn't matter if someone forges those DNS records because you're looking up a URI in the NAI domain that you were given. You verify that the web cert, for example.com, is valid from your web root CAs. You download whatever you find there. And then there's stuff inside those certificates, RFC 4304, among others, which can contain network identification information. And now you have a network you can connect to. you know the CA that signed the server cert, you know your domain, you pick EAT TLS as it says in the document, or TTLS, some TLS-based EAT method, and you can authenticate knowing that the EAT server you're talking to has a chain of trust going back to the HTTP server and the web PKI. So we go to the next slide. There's a lot of details in the draft about variations of all this. There's a lot of questions about what happens in this situation or this situation. That's all covered. There's lots of details in the draft about what doesn't work and why these things don't work. Initially, the first pass really only needs DNS and web configured on the server side and a client space user utility on the client side, and no real changes to the supplicant code. So next slide. So it only works for TLS-based EAT types, so stuff like EAT PWD doesn't use this, unfortunately, or can't use this. It does require some network access to Bootstrap. There are possibilities of using unauthenticated EAT TLS to get any network access. And so the goal is, for example, one use case is, 10,000 university students want to get into eduroam. They have a username and a password, and they just connect to eduroam with unauthenticated EAT TLS, do some lookups for the university, get the certificate information, and then reconnect with full authentication. There can be more benefits, which means moving some more checks to supplicants, potentially adding some new EKU fields, but the document is very long and goes through things in hopefully exhaustive detail and covers a lot of issues. Next slide. So you can work in captive portals to get your configuration, or if you have LTE, you can bootstrap Wi-Fi. Minimal EAP server side changes required, no code changes on DNS or web servers. Your configuration can be refreshed. The document talks about how configuration refresh works. Can follow a process, so the user UI can follow a process similar to web UIs, but for network access. Hey, we're connecting to this network. By the way, I've checked the EAP server certificate. There is a chain of trust. It is example.com. You are allowed to enter your password so your name and password for Alan at example.com into this Wi-Fi pop-up. So next slide. There's running code, couple of Docker images. So you specify a couple of things. Hey, I want to pretend to be this domain. You can create some fake CAs and fake certificates, and it sets up the client and the DNS server and the web server and the radio server. And then it runs this 300-line Python script, which looks stuff up and spits out configurations for WPA supplicant or for Apple and their mobile config. And this is, every piece of this configuration has been trusted and verified. So there's no need for trust on first use anymore. Next slide. It seems simple enough. There's been a couple people who've reviewed it and sort of kicked at it a bit. We could deploy it today with device utilities, as in an extra utility that you run in your client device, which configures your supplicant. The first pass does not require code changes in the supplicant or the server side. Just here's a couple magic records in DNS. Here's a couple well-known places in the web to put certificates. Every client runs a small utility, and 30 seconds later, your TLS-based EAT methods are configured. Comments, that's it.
in the queue?
Dan Harkins. Thanks, Alan. So in your example, you had Alice doing a DNS lookup for Bob's certificate, but doesn't DNS require IP connectivity, and this is still an EAP? So how are you?
So yes, this is all very true. It does require some network connectivity. So there are two ways to do this. One is, for example, you have a phone and you're trying to connect to eduroam. You still have LTE or 4G, 5G backhaul. You can do your lookups there. Or what isn't so much in the current document, but does need to be fleshed out a bit, is you should be able to just connect to the SSID with unauthenticated EAP TLS. And this was some of my comments on the list about, hey, we need a positive signal that you're trying to do EAP TLS by using an outer username of something like provisioning at eap.arpa. And now the EAP server knows, hey, I'm going to put you in a captive portal. You have network connectivity. You can do 4 DNS lookups, a couple of web downloads. You get your configuration. You drop the Wi-Fi connection. You bring it back up again with your new EAP configuration, and it all should just work.
Okay, thank you.
Hi, Alan. This is Sean Turner. Just a quick question. Are we requiring it to be pinned to the web PKI, or is this kind of like a simple enough? You just load. You need some trust anchors, so you're gonna load the ones that are most available.
Yeah, this is just a trust anchor. The current code that's there in the GitHub repo, in fact, doesn't verify the web server certificate, whatever, right? You can always pass the correct options. The key thing I'm trying to do here is leverage some pre-existing network connectivity and pre-existing trust to walk a chain of information to get your EAP configuration. So the easiest thing is just use the web PKI and put stuff on .well-known. But yeah, it could be anything else. Yeah.
Fair enough. So I mean, like, because there's multiple places where you can get trust anchors from, so it kind of long as whatever your EAP client is doing gets back to its trust anchor store, that's enough. It's not like you must use, you know, this particular web PKI store. So I think that makes sense. Okay, thanks.
Joe, you are in queue.
Yeah, just to clarify, you use the web PKI to authenticate the web server, or whatever. You have some PKI, you can authenticate the web server, and then from there you get your trust routes for your EAP connections. That's the basic?
Yes. Thing? Right, like EST, there's a .well-known/CA, right? Mm-hmm. Or .well-known/EST/CA. Well, we could have a .well-known/EAP/CA. And if you trust that web server, you trust it to give you your EAP CA. And then the issue as to whether or not that EAP CA is already known or is a private CA, it doesn't matter anymore to a large extent. And there's a lot of discussion in the document too that I didn't even get at here about application-specific trust anchors. The problem with a lot of implementations right now is the CA stores on a device are, wave your hands, largely global, which means as soon as one of these MDM vendors puts a new CA on so that you can issue certificates for your local company, that CA can now issue certificates for Google too. And so there's a big discussion in the document of, hey, either you have to have a different CA store for EAP, or you have to effectively be able to mark up those CAs as saying, hey, trust this one for web and trust this one for EAP, but don't cross confuse the issues. For example, some of the tests that people have done is, war driving. You go around a university campus and you create a fake SSID on your laptop. You create your own fake CA. You sign certificates for your university, which contain all the university addresses, but they're from this unknown CA, and you broadcast an eduroam SSID. And there are a good chunk of devices which simply never notice, or the information they provide to the user is completely useless. And so the devices will go, oh, that's a CA I've never seen before. Oh, but it's an SSID I've trusted in the past. Here's my name and password. And the document suggests that this might be the wrong behavior.
Could you, Joe, go back a couple of slides to slide 7? I think I had a question here, but I don't know if I remember it anymore. So, yeah, I don't remember what was exactly the question. Maybe something to do with this lock is green. So I guess, yeah, okay.
So the reason I put that up there is right now when you connect to Wi-Fi on pretty much anything, you have no idea whether or not the server certificate is okay, whether it's from a known CA. It's completely opaque. I have a bunch of screenshots from different devices, different vendors, where they do things like put up the fingerprint of the server certificate and say, is this okay? And the user has absolutely no way of telling whether or not that's okay. Whereas instead, if there was some way to get trusted configuration and trusted EAP CA, then when the user tries to connect, the supplicant can connect to the server and go, hey, it's a server for example.com, and it's signed by a CA I know. This is exactly what we do with the web. It works. And therefore, show that to the user. Hey, this is a trusted SSID. And that kind of thing can be used for different SSIDs, right? So the draft talks about how to configure SSIDs, but let's say the user wants to connect to an SSID that he doesn't know about, right? He should be able to just click an SSID and get told, yes, the server the server certificate is trusted or not. And if it's trusted, then you can send over your credentials, and if it's not trusted, you can't. Anyway, the draft is long, as I said, almost 60 pages. It goes into a lot of detail about a lot of different issues. What I'm trying to do here is just sort of give the 10,000 foot picture of if we leverage a pre-existing trust. The examples here are WebPKI, then we can get a chain of trust which ends up allowing the supplicant to configure EAP. And the end user, for the user portion of this, from the end user side, all they've done is enter, my name is alan@example.com and my password is super secret. Magic happens behind the scenes, and then they get a secure Wi-Fi connection that they can trust. That's a little better than what happens today, which is, I think at best we can describe it as painful. I mean, anyone who's gotten a new device and tried to get Wi-Fi configured to a secure corporate network, your choices really are banging your head against the wall or downloading some MDM software. And then what happens, right? And this is a
Okay.
question too, which is if you download some MDM software with the CA that comes from your corporation onto your personal device, effectively they can pretend to be Google, they can pretend to be anyone. And what exactly does that mean for your own security?
Okay, yeah, thanks. I think that answers my question. Maybe while we are still at this slide, and if there's time for one more question, how, I'm not sure how this or how does EAP work with captive portals in general, and then could you expand a little bit more? What does it mean that it works with captive portals?
So the issue right now is captive portals, by and large, don't do EAP, and you're left with some human reading some web page, trying to figure out what to do and whether or not they have to enter their credit card information, for example, in an airport. The nice thing about using unauthenticated TLS, especially if we can use a realm like EAP.ARPA, is you just define this captive portal walled garden to be the provisioning walled garden, and the only things you can do in there are provisioning, and then the user doesn't have to read any web pages, right? You just do your provisioning here, DNS lookups, web server lookups, and go on from there. So the point and the hope here is to take the person out of this process. You know, having pop-ups to say, is this server certificate valid? This is what I do for a living. I have no idea what to do with those pop-ups. And if instead my process is, here's my name and password, and I get on, I have a lot more confidence in that. So yeah, removing the human from the captive portal approach, I think, is beneficial for everyone.
Okay, thanks. I don't have any other questions. Thanks.
Cool. So I think it would be great to have more discussion of this on the list. And there's definitely things we want to look into here. I mean, making this experience better is a good thing. So thanks, Alan. All right. Next up, I think we have EAP DPP. Is that going to be Dan or Owen? Do you guys want to present or do you want me to present?
I'll present. I'll try. I'll see what happens.
All right, it's an experiment. Maybe I have to stop first.
I did a slide request. It says no slides available. What? Choose a deck to share. You know what, Joe? Why don't you display?
Okay, there's a difference between sharing a display and sharing a screen. Or sharing a presentation.
Okay, great. Can you do full screen? There we go. So thank you. My name is Dan Harkins. Owen and I have been working on this for some time now. We got some comments from the TLS group and I'd like to bring it back into EMU. So next slide, please. So a little bit of background. The Wi-Fi Alliance has defined this thing, the device provisioning protocol, that will take a public key and use it to bootstrap a client into a Wi-Fi network. And what happens then is the client gets a guarantee that he's connecting to the right network, being defined as the one that knows his bootstrapping public key. and the network has a guarantee that it's provisioning the right client because it's the one that knows the corresponding private key. This trust model, of course, assumes that the key database has some strong integrity. The whole security of DPP depends upon that. This bootstrapping public key is basically a base64 encoded ASN.1 sequence of a subject public key info, and it's transferred in a URI that looks like this, DPP colon, and then a bunch of goo. The format of that is in the DPP spec, but everything following the K colon there is the base64 encoded key. The important thing here is the key is a raw key. It's not required to be in a PKI. It could be static and bound to that device, or it could be dynamic. And if the device is a GUI, it could display its key in the form of, let's say, a QR code on the GUI, or the device, the infrastructure could download this URI from the cloud if you want to do a kind of true zero-touch experience. But once the infrastructure has gotten this key and authenticated the device can be given a credential that will allow it to get on any possible network. It can get a PSK or a password. It can get a certificate if it needs it, and it can get a thing called a connector, which is sort of like a Goldilocks credential. It's not quite as weak as a PSK, but it's not quite as intense as a certificate. It's sort of like right in the middle. So next slide, please. So here's an overview of DPP. So the infrastructure is getting this URI, either scanning a QR code or doing NFC or getting it from the cloud or something. And coincident with that, or maybe before that, this device is doing what's known as a chirp, and it's chirping out, announcing its presence, and the infrastructure will then use that to discover this device and use the bootstrapping key that it has downloaded to authenticate the device. Once it's been authenticated, it can provision it with a credential that's appropriate for the particular network that the device should be connecting to, and then the device uses that credential to connect to the network. Next slide, please. So if you're paying attention, you're going to say, well, that's great, Dan, but what does this have to do with EMU? And that is a fantastic question. So DPP solves the catch-22 problem of where you need a credential to get a credential, but DPP is for .11 only. And it doesn't work for any sort of other medium. So what we want to do is we want to use the same sort of DPP bootstrapping techniques, either getting the public key from the cloud or from a QR code that's in a BOM or on the device's backside, or using NFC or whatever the various schemes that DPP has provided. We want to use that to establish trust across both Wi-Fi networks and wired deployments. So we want to use that public key to solve the same catch-22 that we have for wired enterprise devices. So what happens is we can use, so .1x is going to do identity request at link up, so there's no sorts of discovery issues involved, there's no chirping necessary. And so, as I mentioned, DPP's .11 only uses these pre-association action frames, but the equivalent for that in wired is EAP. So we can use EAP to do this sort of authentication. So what we then need to do is use that to authenticate a TEAP exchange, and then use TEAP's existing S-like exchange to provision a device, a certificate on the device. Next slide, please. So what we need to do then is use this bootstrapping key to authenticate TLS. So what we do is we take the bootstrapping key and we use it to drive two data. One is an identifier that identifies what key to use, and the other one is a PSK that we use for TLS authentication. We can then use that PSK with RFC 8773, which defines how to use an external PSK with TLS authentication, and we use that derived PSK. So that will provide proof to the client that the server really knows his public key. It also proves to the client that the server proves by the server that the client knows the public key. But also, we can use RFC 7250, which is TLS with a raw public key, where the client can use his bootstrapping key to sign his particular share. And that will provide an additional proof to the server that the client has the corresponding private key. We signal all of this with a new name coming out of the extensible PSKs registry that's being defined by this draft here. So we're not actually requiring any changes to anything. There's nothing that changes in TEEP. There's nothing that changes in 8773, nothing that changes in 7250. And all we do is ask for a name from a registry of names that's being defined for that purpose. Next slide, please. So here's how it looks in TLS. The plain normal font is the existing TLS exchange. The boldface stuff is what's present for bootstrapping with DPP, and the red stuff is the new stuff we added. So we're just adding, this BS key identifier from the extended PSKs draft, and then we're adding the using the cert with external PSK from 8773, and we're indicating that the client will be using a raw public key from 7250. And other than that, it's straight old TLS. Next slide, please. And so how this all hooks into EAP then, to draw back to that question you all had, well, we're going to use this to authenticate again with TEEP. So what happens is at link up, the authenticator is going to say, who are you? And the client having no knowledge of anything whatsoever, doesn't know what his realm is, he's just going to say TLS poke. Now there was a discussion on the list about whether this should be TLS poke.arpa or something like that. Whatever, we can decide that later. But the idea is that the client responds with just some static identity saying, I'm one of these weird bootstrapping people. And the authenticator then will initiate TEEP, and TEEP will be authenticated with TLS DPP using the bootstrapping key that the authenticator has obtained using whatever DPP bootstrapping method. Once that's been authenticated, then we just do the regular old TEEP S-like exchange where there's a CSR attributes TLV, followed by a PKCS10 TLV, a PKCS7 TLV, and then the supplicant now has been enrolled in the CA, and all of his subsequent network connections will use this certificate that he's been provisioned with. Next slide, please. So where we are is we're on 03 of the spec. I hope everyone has had a chance to read it. We do have some running code for the TLS portion of it. Owen has implemented this in Mint. And at this point in time, Owen presented this to TLS yesterday, and they had no real comments about or concerns with our TLS approach. So what we're wondering is if this can be adopted as a work item in EMU as a solution to this general IoT problem that many of us have. End of presentation.
Okay, are there any folks who want to speak up now about their opinions about adopting or not adopting this draft? Interest in this draft, either positive or negative?
Anybody read it?
Yeah, how many people have read DPP? You can put a +1 in the.
I'll shamelessly do a +1 myself.
So we have a few folks. I think we're going to need to get a few more interested parties in order to make sure that we have enough folks to do the review. So let's kind of work offline to see if that's something we can do so that, yeah, can we get some volunteers who are interested in reviewing this draft as well? Okay, so I think that's something we need to work on,
Mhm.
okay? And then I think if we can have a little more discussion on the list, then we can see if it's appropriate to.
It's late Thursday. Yes, it
Yeah.
is.
And yeah, for some locations, it's may even be Friday already. All right.
Okay, thank you.
Thanks. Let's move on to Mylene, next presentation.
Tell me.
Okay, whenever you're ready, and I can change the slides for you.
Okay. 6. Hello. I'm Meilin Chen from China Mobile. In this draft, we propose a method of using identity as raw public key in EAPTLS. The core idea is that we use identity-based signatures for authentication instead of just relying on CA certificates. Next slide, please. We already gave a presentation at the IETF 109. Also, some comments were received. We can review it together. The first question is what scenario it is for. The scenario is for Internet of Things devices, especially for passive long life device. And other scenarios is also suitable. Is it related to IBE? We just use IBS signature to slow the identity's authentication problem, not use the identity-based encryption here. Any running code, we make an implementation in our local network. We coding EFTS IBS based on the EFTS 1.2 and using ECCESI. And another question is any cross scope of IoT OPS? I have checked the charter of the work group. I think they have no cross scope. Next slide, please. At present, the version is have been updated to version 02. Detailed modifications can be seen in the draft by the virtual tools. So the slide just give a summary. We have 2 updates and 2 new A's. The first update is in object, which is a reference of draft IETF details 13. The second update is in the introduction. We add a text description in the draft IETF EMUEAPTS 13 reads certificates can be of any type supported by TLS, including raw public keys, and in RFC 13.2 and 15, it assuming that an out-of-band mechanism is used to bind the public key to the entity presenting the key. These 2 tips is suitable for our jet. It is sure that we haven't taken the key distribution into our jet scope. And the 2 new A's is, the first one is in IANA consideration part. So this document registers the following items in the merged types. Registry under the extensible authentication protocol registry heading And the second, the new is in use cases of the IETF IBS in section 3. The one is used for authentication of IoT, and the other is used for systems that do not support CA certificates. Maybe it can just aid as an optional choice. If there are any other use case requirements we received from the comments, we will also increase this part of the use case. Next slide, please. We update the process in Figure 7, Figure 8, and Figure 9. We add a round-trip interaction based on the draft IETF EMU EAPTS 13, the version 18. After TLS finished the message sent from EAP server, no more commitment message sent. And after TLS finished the message sent from authenticating peer, EAP server will return an EAP request message with TLS application date 0x00. Then authenticating peer give a response. Finally, is AAP success, which flagged the end of the procedure. Next slide, thanks. Thanks to Ross Catalyst, when I want to give up this draft, he find me by email and express Catalyst. He would do the SN.1 structures for PES1 modules when it becomes an RFC, and will review the part ASN.1 portion of the specification to make sure they are clear. So we will continue with this draft for update. What we'll do next, we will define the key derivation based on EAPTS IBS. If this draft becomes a workgroup draft, one thing you need to do is that EAPTS-based type needs to add a new type for EAPTS IBS. In the workgroup item draft IETF, EMUTS, EAP types. And the next step, we want to try to call for adoption. Thanks and comments.
Do we have anybody who wants to comment on this particular draft and whether it's something the working group should take on or not? And also, how many folks have has anybody read this draft in +1 in the chat? Sean?
I'll be real quick. I'm not a lover of the identity-based encryption or identity-based signature stuff at all, but also I'm okay with people exploring and doing whatever they want. So I'm okay with this progressing, whether it's in the working group or you sponsored or whatever. I have no problem with that. I don't really have an opinion whether it should be whether it must be in the working group or not. So that's all I really want to say. Thanks.
Thanks.
Right now, it doesn't show that we have anybody who's kind of read the draft on the call today. So I think what we need to do is make sure that we have people who are interested in working on this draft in order to kind of bring it into the working group. It's possible to take drafts also through various individual mechanisms if they don't have sufficient interest in the working group. But I think the next steps are trying to get some more people interested in this use case.
Yes, I do know how many people have read the draft. So maybe after the discussion, we can send the mail list and ask for artists for comments and have a quick look at my draft. And I do not sure it is enough to ask for adoption.
Yeah, I don't, yeah, so I think we need to, I don't think we have enough right now, at least not based on this particular call. So I think, additional discussion on the list would be good for this draft.
Okay. Okay, thanks.
All right, I think we've reached close to the end of this session. Are there any other topics people would want to bring up? All right, well, if there are no other topics, thanks everybody for participating, and we'll see you on the list.
Good night.